Hello everyone. Today we are going to understand basically how the flow over automotive vehicles happen, and really the target is to uh, get a good conceptual understanding of flow-induced vibrations and noise. So, in order to understand how the noise and vibrations are incorporated during vehicle movement, we need to first understand how the flow over vehicle happens. And there are many benefits, there are many objectives of really studying and understanding the flow over vehicles. The first is to reduce fuel consumption. So, for instance, you look at this slide. One of the objectives is to reduce fuel consumption. So if you have a high drag coefficient, then obviously you will consume more fuel. There will be a lot of resistance for the vehicle, for the movement of the vehicle. And so hence this is one of the primary objectives to study. Then there is also comfort characteristics, whether your vehicle is comfortable for the passengers. So that's what we will look into. There's also driving characteristics like whether it is going to be stable, whether it can handle the traffic safely. Okay, and there are many ways you can understand this vehicle aerodynamics, but what we are going to mostly look at is flow past the vehicle body. Okay, and so we'll look at the next slide. Now in this, really how the aerodynamics of the vehicles have evolved over a period of time is shown. So from 1900s to 1920, the shapes of the vehicles were adapted from other fields like uh, aero engines, from the torpedo, from the airships, and from the boot, and so on. Then the adaptation continued uh, with some experimentation that was started from 1920s to 1970s. The whole point was to make the shape of the vehicle a bit more streamlined. And in from 1970s to 1990s, there was detailed optimization that was carried out. So experiments were carried out in order to understand how the streamline flow will happen across the body of the vehicle. And there were many experiments that were carried out during this period. So from 1990s and beyond, there were a lot of improvements in the vehicle body, the shape, the aerodynamic shape of the vehicle, and that kind of reduced the flow, induced vibrations and noise in the vehicle. You can see a lot of different vehicles are shown over here based on the drag and how those were evolved over a period of time from say 1920s, 30, 40, 50 and so on. And overall the drag coefficient was is reduced, and it's even going down. So there is a lot of improvement that goes on and a lot of research and development that goes on uh, in the shape size of the vehicle. There are many small experiments that can be carried out in order to understand the complex flow over a vehicle, how really the flow happens across the front side, the side walls, the rear wall, and the underbody. So these are some of the important definitions that we have covered today. In the next presentation, we will go in depth of all this, as well as we'll understand how the body line flow is, how the separation occurs, and how the bubble occurs. So all this will cover in the next presentation. How you can reduce the flow induced noise and vibrations, all those also we will cover. Thank you.